Hello and welcome. My name is Nate Hayden and I am Levo's Research and Development Director. This video is the second in Levo International's training series on fertilizer use in hydroponics. This video will cover the basics of setting up and maintaining a balanced nutrient solution in simplified hydroponic systems. First of all, I want to thank the Northeast SARE who provided funding that enabled us to carry out this research optimizing our fertilizer protocols and also to make these training videos. We received support from the SARE through a farmer's grant in the Northeast region. Additional support for this research described in this video and some of the work that we did was provided by a Connecticut Department of Agriculture Specialty Crop Block Grant. So jumping right in, electrical conductivity, or EC, is one of the most common measurements that hydroponic farmers use to track nutrient content. And you can see this online if you Google different things about how to use fertilizers in hydroponics. And you can find a lot of recommendations for EC levels for different crops online. EC can be measured quickly and relatively cheaply with a meter. The fertilizers used in hydroponic systems come in salt form, and so they impact the conduction of electricity in the solution. Higher salt concentrations in general will promote a higher electrical conductivity. And EC can therefore be useful to measure and really to estimate fertilizer content in a hydroponic system. However, it's really critical to keep in mind the limitations of what EC actually is. It's not a true measurement of fertilizer content because different salts affect the EC differently. For example, EC cannot tell you how much calcium or nitrate there is in your nutrient solution specifically. And different salts, so that calcium that's present or a compound containing nitrate in the nutrient solution, those concentrations will affect the EC differently. So it's not like one nutrient unit affects it a certain amount. Each compound, each ion will affect the conduction of electricity a little bit differently. And so it's very difficult to take an EC reading and know exactly how much of any individual nutrient is present. So we wanted to verify this and see if there was a relationship between electrical conductivity and any of our individual nutrients as the plants were growing in our systems. And so we conducted a study looking at this, and we found that there really wasn't a strong relationship between any of these individual nutrients and electrical conductivity. So you can see here on the y-axis of the top left figure, nitrate versus EC. On the y-axis, we have nitrate, and then on the x-axis, we have EC. And we don't see here a clear relationship between these, at least not on a linear basis. So as that EC increases, we don't see a clear, regular corresponding increase in the concentration of nitrate. And this was also true across the board for the other nutrients like phosphorus, potassium, calcium, magnesium, sulfur, and any of the other nutrients that we looked at. We didn't really see a clear relationship between EC and those nutrients. And so that made us really think about how we were using EC to make decisions. And we expect that we're not seeing this because of that differential uptake of individual nutrients at different rates and the different effects that these nutrients will have over time. And so because plants take up nutrients at different rates, and because EC cannot tell us exactly how much of any individual nutrient there is, how can we use EC to inform our growing and our fertilizer use? So what we've been doing is that we primarily use EC as a warning that something has gone wrong with our typical protocols and their execution. So for each crop, we have established low and high threshold values. If we get an EC reading outside of these threshold values, we know that either a fertilizer addition has not been made when it should have been, or too much fertilizer has been added. For example, maybe somebody added fertilizer in the morning and somebody came in the afternoon and added more fertilizer, not knowing that it had already been added. This will show up as a clear spike in the EC value, and we'll see that something clearly has gone wrong with our protocol execution. However, we do not generally recommend making fertilizer additions to target specific EC values or using these EC values to decide when to add or when not to add fertilizer for the most part, outside of this use as a high or low threshold. So this fits in with our overall innovative fertilizer strategy. So due to all these issues that I've talked about already, hydroponic producers frequently replace much or all of their nutrient solution to avoid imbalances in nutrient content and to just kind of get rid of the guesswork, because there's no real easy way for them to know what's there, so they just constantly replace the nutrient solution. This is completely understandable, but it's a big waste or a big use of both water and fertilizer that could be avoided theoretically. And so in order to do this, to prevent this waste, we at Levo have developed an approach to use lower fertilizer additions repeatedly over time. So adding in smaller amounts, that way we don't get too much of anything during the plant production cycle. So this enables us to keep nutrients in balance with each other and to continually keep them in a range that's acceptable for optimal plant growth. Despite these different uptake rates that plants have, and despite this limited information that EC provides, we're able to use this slow addition approach to prevent us from having to constantly replace a nutrient solution like is often done. So how we do this is we use just the recommended addition of our fertilizer mix. So we use the 5-12-26 NPK JAX Part A and the 15-00 NPK JAX Part B. At its recommended application rate on the label to start off with. And then we do this across the board for different crops. Then during crop production, we make periodic additions of half-strength fertilizer. So shown here, we use half of that initial value that we're adding in, so a small amount that we're periodically adding in. How much are we doing this? How frequently are we doing this? That's where we can adjust things based on the crop in question, because different plants will have higher or lower nutritional needs, and they'll like more or less fertilizer being added. So the frequency of these half-strength additions is primarily determined by crop type, but the amount of plants per volume of nutrient solution is also a critical consideration, because that will affect the rate of uptake of nutrients. And so you can see here some examples that we use for different crops. Generally we make this addition between 2 and 4 weeks. But I do recommend that if possible, you carry out some preliminary trials testing different application rates within your systems. And if you're able to do specific nutrient tracking within that, that's even better. But generally just seeing how the crop responds within this range of making additions every 2 to 4 weeks, using a standard, within the range of standard amount of nutrient solution per plant, should generally get you acceptable results within what you'd expect. Mm-hmm. And so we went and we validated our approach for our own systems, and this is some data that I have from a pepper trial. And we found that the values of those specific nutrients stayed within the optimal ranges for using this approach. And so you can see, for example, looking at nitrate on the top left in panel A, we have nitrate concentration in parts per million on the y-axis, and we have a day on the x-axis, and each of these points is a separate reading from a different system, and the dotted line is the range that we want it to be within. So we saw that throughout this sampling, we saw that it was within that range, and we see that for the most part for other nutrients, though We do have some exceptions. So, for example, our phosphorus levels got a little bit low, and our potassium levels got a little bit low near the end when the plants were fruiting. And so this led us to understand that we need to actually maybe add a little bit more as the plants get bigger. And so we've now adjusted our protocol for peppers to do more frequent additions near the end of their life cycle when we're harvesting, so that we can keep the phosphorus and potassium up high. In addition, the biggest thing that we took away was that nitrate levels frequently dropped really low in our system, and this was not reflected by a drop in EC, and so this has gone undetected by us for a while. So we've seen this, and we are going to implement additional calcium nitrate additions to make sure that the nitrate levels remain within our optimal range, and nitrogen in the form of nitrate in this case is really critical for leafy growth and for optimal plant production. So it's really critical that we make this adjustment. And in order to make sure that we do this well, we're going to conduct nitrate specific testing to decide when those calcium nitrate additions should be made. So we can't use EC. We're not sure exactly when we should be optimally making these additions. And so we're going to use specific testing for nitrate. And one thing that we discovered in one of our research projects was that we can use a relatively cheap nitrate test to do this. It gives us enough data. It's not giving us this really, really specific, but it gives us a good enough idea of how much nitrate's present to be able to make decisions. And so these tests there's several different brands that are available, but they're designed for use in home aquariums. And they worked really well in our trials to measure nitrate concentrations in our systems. And I have an example pictured here from the paper that we recently published in the journal Methods X. And so we now use these test kits to specifically test and check our nitrate levels in our systems, and that's going to allow us to get better and better at actually timing the calcium nitrate additions. So we have the general protocol of when we add an initial amount of fertilizer based on the recommendations from the manufacturer. Then we make periodic half-strength additions. And we're going to add in an extra calcium nitrate addition based on specific nitrate testing. But we use those regular intervals, which can change depending on if it's in a leafy stage or if we're in a fruiting stage. But we use that general protocol. And one last point that I want to make is that we want to err on the side of caution. It's usually better to not, and easier to fix, to not have enough generally fertilizer added than it is to fix the problem when you have too much, because then you can run into issues with toxicity. The salt content being too high can cause a lot of problems for the plants, and it's much harder to overcome that kind of issue. And then also you're going to end up wasting a lot of water and fertilizer potentially if you do that. And so just a caution with this kind of approach is really critical. So thank you very much for listening, and happy growing, and enjoy the rest of your day.